the last lesson in Chapter 8, we're going to go back to 8.3. So 8.3 is applying the skill of solving quadratic equations to solve equations that are in quadratic form, which means they may not go squared x number. They might go something like 4 2 constant, or 4/3 2/3 constant, or x plus 5 all squared, x plus 5 constant. But these are all in quadratic form, because to be in quadratic form, all that matters is that the variable on the exponent is something, and then half that something, and then gone. So if you look at this one, we've got 4 2, which is half of 4, and then gone. Here we've got 4/3, and then half of 4/3 is, if I simplify, 2/3. So it goes 4/3, half of 4/3, and then gone. Here we've got squared, 1, gone. So these are all what we call in quadratic form. And what we're going to do is solve them using the same skills that we learned in this chapter, and then put them back into the form they originally are in. So the first skill that you need to learn is just replacing the variables with u. And the reason we do this is because it's going to look like it should. So we go 2u squared plus 5u minus 12 equals 0. And then this is quadratic, right? Because quadratic, the highest exponent has to be a 2. This one, the highest exponent was 4. So we did a u substitution. Now, what did we substitute u in for? Well, u is that middle term. So it's the x squared. So let's do this one. Again, you've got 1x to the 4/3. So we have 1u squared minus 8u plus 16 equals 0. This is in quadratic form with a u substitution. The u replaced x to the 2/3. Same thing here. We've got a coefficient of 2, so we're going to have 2u squared minus 7u plus 6 is equal to 0. This is your quadratic form of this original equation. And again, our u substitution was that u replaced x plus 5. So that's the first skill, is being able to take something that's quadratic-y and make it into an actual quadratic with a u substitution. Now, how do we actually solve? Well, here's an example. I'm going to take that 2x to the 4 plus 5x squared minus 12 equals 0. I'm going to do a u substitution, so I'm going to substitute u for x squared, so that I get 2u squared plus 5u minus 12 equals 0. And now I'm going to solve this. Now, every single question, once it's quadratic, you can solve by factoring, square root method, completing the square, or the quadratic formula. In Math 50, because this is a new skill of making it quadratic, every single one of the questions in your assignment will be able to be solved using factoring. But if you want to use any of the other methods, please feel free. So we're going to solve this one by factoring. We're going to use the AC method. So we're looking for two numbers that multiply to give me negative 24 and add to give me positive 5, which is 8 and negative 3. So then we solve by decomposition. We'd make 5u into 8u minus 3u, and then we're going to factor by grouping. So we're going to greatest common factor out 2u to be left with u plus 4. We're going to greatest common factor out negative 3 to be left with u plus 4. Then we're going to greatest common factor out that u plus 4 to be left with 2u minus 3. Then, because this is equal to 0, we're going to use our zero factor property. So we've set it equal to 0 and we've factored. Now we're going to set each factor equal to 0. So u would equal negative 4 and u equal to 3/2. And this part here that we've done, this isn't anything new. This is what you're used to doing. The new part is that we weren't actually solving for u. We were solving for x squared. So what you'll then do is replace that u back with that x squared. So you'll say x squared equals negative 4 and x squared equals 3/2. And then we're going to solve for x. To solve for x, you're going to take the square root, so we're going to solve algebraically. You're left with x equals plus or minus the square root of negative 4. You can't take the square root of negative 4, not get a real answer, you just get an imaginary answer, so we're going to say no real solutions. We're also going to take plus or minus the square root of 3/2. Now this is not simplified because it has a radical in the denominator, so we're going to multiply top and bottom by root 2 to end up with plus or minus root 6/2. So my only two answers are plus or minus root 6 divided by 2. And I can double check to make sure that these work by plugging them into the original equation. So this is it. So it's a big one. It's extending our knowledge to be able to solve equations that are what we call quadratic-y. So let's do the next two that we used as examples. So the first thing we do is our u substitution. U squared, so take the coefficient and put it on u squared minus 8u plus 16 is equal to 0. Make sure you know what you substituted u for. So u is x to the 2/3 because we're going to have to substitute that back in. Now we're going to solve this equation that is quadratic by factoring. Like I said, all of them solve by factoring. If you don't like factoring, you can solve using completing the square. You can solve by using the quadratic formula. But for most people, factoring is the quickest. So we're looking for two numbers that multiply to give me positive 16 and add to give me negative 8. So that would be negative 4 and negative 4. You can do the whole decomposition method if you want, or you can know by now that it factors down to these two brackets. U minus 4 times u minus 4. And again, I could do that because the leading coefficient was a 1. So u times u is u squared. Negative 4 times negative 4 is 16. And then my OI, my outer and my inners, would give me negative 4u minus 4u gives me minus 8u. Now that I've factored it, I can set my factors equal to 0. So u would equal 4. And this also gives me u is equal to 4. So I only need one of those solutions. So I'm going to say u equals 4. But I didn't want to solve for u, I wanted to solve for x to the 2/3. So I'm going to replace my u with an x to the 2/3 is equal to 4. Now I need to solve for x. So I'm going to solve algebraically. I have to undo the square and I have to undo the cubed root. So I'm going to do them one at a time. So because I have a cubed root, I'm going to cube it. So those are opposite operations. What I do to one side, I want to do to the other. I end up with x squared is equal to 64. And now I want to solve for x by taking a square root. Don't forget, every time you take a square root, you need a plus minus. So x would equal plus or minus the square root of 64, which is 8. So then what you should do is always check these. Now these ones should work because it's a cubed root denominator. If it's a square root denominator, always check, right? Because sometimes you get those extraneous solutions, or my solutions are just proposed solutions. But if I plug these back in, if I quickly did it, I do end up getting 0 equal to 0. Okay, next one. Again, start with your u substitution. So we've got 2u squared minus 7u plus 6 is equal to 0. U is x plus 5. Okay, now we're going to solve this. Again, every single one you can solve by factoring. If you hate factoring, feel free to complete the square or use the quadratic formula. It'll work the same. But we're trying to solve for u. So we're looking for two numbers that multiply to give me 12 and add to give me negative 7. So they both have to be negative. So we've got what? Negative 3 and negative 4. So we're going to go minus 3u minus 4u plus 6 is equal to 0. Then we're going to factor by grouping. So we're going to go u times 2u minus 3 minus 2 times 2u minus 3 equals 0. Greatest common factor out 2u minus 3 to be left with u minus 2 equals 0. Now that I've factored it, I'm going to set each factor equal to 0. So 2u minus 3 equals 0. I'm going to add 3 and I'm going to divide by 2. For this one, u minus 2 equals 0. I'm going to add 2 and I get u equals 2. So my two solutions are u equals 3/2 and u equals 2. But we weren't trying to solve for u. So they choose u because u is a variable that's like kind of never used to remind you that you have to substitute back in. So we've got x plus 5 equal to 3/2, and we've got x plus 5 is equal to 2. To solve this, I'm going to subtract 5. I get x is equal to 3/2 minus 10/2, right? So 5 over 1, create a common denominator. I get negative 7/2. For this one, I'm going to subtract 5, and I get x equals negative 3. And again, there's nothing in here that should make these proposed solutions. These should be solutions. There's no square roots, there's no denominators, and so you can check them, but I know that both of these solutions work. All right, last one. This one's a little bit tricky. There's a couple different ways of doing this one. I find the easiest thing is to notice that this is a squared. So I'm going to make this one my leading term. So I'm going to make this all equal to 0. So I'm going to have 6 over 2p plus 2 all squared. And then I'm going to subtract, well actually I'm going to add this whole 7 over 2p plus 2. And then I'm going to subtract the 3. So I'm just getting rid of them on this side. So I have to add this guy and I have to subtract this guy. Now, to help you understand what the variable is going to be, I'm going to write these numbers as coefficients. I'm going to write them out front. This would be 6 times 1 over 2p plus 2 all squared, plus 7 times 1 over 2p plus 2 minus 3. So that you can see that this would be 6u squared plus 7u minus 3. So my u is 1 over 2p plus 2. Now some people would take this equation and get rid of the denominators first, which will work. You could multiply everything by 2p plus 2 all squared and we'll end up with the same answer. I'm just going to try to keep it the way that it was written in the question. So we're going to replace it like this. And then we're going to factor to solve. So my target number is -18, so that's going to be +9 and -2. We've got 6u squared plus 9u minus 2u minus 3. Factor by grouping. Out of this first group, I'm going to take out a 3u to be left with 2u plus 3. Here, I can't take out anything except I'm always going to take the sign of the first term. So I'm going to take out a -1 to be left with 2u plus 3. So that my greatest common factor is 2u plus 3, and I'm left with 3u minus 1. Now I'm going to set each of these factors equal to 0. So 2u plus 3 equals 0 when 2u equals -3, when u equals -3 halves. For this one, 3u minus 1 equals 0. When 3u equals 1, when u equals 1/3. Whew. All right. Now, we weren't solving for u. We were solving for 1 over 2p plus 2. So now I'm going to replace the u with 1 over 2p plus 2 in both of these scenarios. And look at this, we are now going to bring in some chapter 6 skills. So we're going to multiply, you can do bottoms up because this is a proportion. You could go multiply by 2, multiply by 2p plus 2. But really what we're doing, and I mean, gosh, you could greatest common factor this first if you wanted to. Yeah, why not? We've got 1 over 2 times p plus 1. There's so many ways to solve these things. So my lowest common denominator is going to be 2 times p plus 1. Now, if you didn't see that and your lowest common denominator was 2p plus 2 times 2, it's not going to be that big of a deal. But because we did this, we can now cross out this denominator and we can cross out the 2. All right, so we are left with 1 equal to -3p minus 3. And now we're going to solve for p. So we're going to add 3. And we get 4 equals -3p. Scrolling down a bit, you get divided by -3. You get p is equal to -4/3. For this one, same thing. We're going to multiply. Now this one, there's no point in greatest common factoring, so I'm going to multiply each side by 3 times 2p plus 2. 3 times 2p plus 2. And again, I'm only allowed to do this because it's an equation, not an expression. So then I simplify. I'm left with 3 equals 2p plus 2. And then I solve. Subtract 2. I get 2p equals 1. Divide by 2. I get p equals 1/2. Now you want to double check that when you plug these in, you don't get 0 for a denominator. So if I plug in +1/2, is that going to make this equal to 0? Well, 2p plus 2 cannot equal 0. So 2p cannot equal -2. So p cannot equal -1. Since neither of these solutions are -1, I'm going to assume they work. To know for sure, I should plug them in with my calculator and check. But I know for sure that 1/2 and -4/3 does work. All right, so that's the end of chapter 8. This was solving equations that are in quadratic form. Good luck.